Welcome to Maths and Science by IITian channel. Now in this lecture, I will be continuing from the previous lecture about sequence and series for Maths Olympiad, JEE Mathematics and also CBSE Maths. And in this I have taken up another series, that is 1 by 1 square into 2 plus 1 by 3 square into 4 plus 1 by 5 square into 6 up to infinity is equal to pi square by 8 minus ln2. This is a very important series and it will be connected to the Riemann integral as I have explained in the previous lecture, and also it can be useful for higher engineering mathematics series like 4-year series also. It's a very good series question. Let us try to solve it. It will be useful for IIT JEE Advanced, IIT JEE Mains, CBSE and Maths Olympiad. Very good question. This is nothing but 1 by 2n minus 1 whole square into 2n. This is 2n and this is 2n minus 1 whole square. N is equal to 1 to infinity. N tends from 1 to infinity. This is whole square. This also, if you see, 3 square is nothing but 2n minus 1 whole square and this is 2n. That means what we have to find out is sigma n is equal to 1 to infinity 1 by 2n minus 1 whole square into 2n is equal to how much? That is pi square by 8 minus ln2. We have to prove it. We have to prove this value. It's a very good example to understand the concepts behind the series functions, and it's a very good series function problem. Infinite series. A function is defined by an infinite series, then its value will be how much? Does that series converge to a fixed value or it will diverge to an infinite value? From the problem, it converges to a fixed value. That value is pi square by 8 minus ln2. That's what we have to prove. Let us try to solve the problem. Question: prove that the infinite series converges to pi square by 8 minus ln2 when series is defined by sum of the series is equal to 1 by 1 square into 1 by 1 square into 2, 1 by 3 square into 4 plus up to infinity. Now, let us try to solve the problem. Solution. What is the nth term? An is equal to 1 by 2n minus 1 whole square into 2n. This is the nth term. Can we expand the nth term? Decompose the nth term? by decomposing nth term, we get an is equal to 1 by 2n minus 1 whole square into 2n is equal to, when we decompose, let us say this can be written as a by 2n. Similar procedure what we have adapted in the previous example. B by 2n minus 1 plus C by 2n minus 1 whole square. Then what happens to an is equal to 1 by 2n minus 1 whole square into 2n is equal to 2n into 2n minus 1 into 2n minus 1. Let us take it as the LCM. Then what happens? 2n minus 1 whole square into A plus B into 2n into 2n minus 1 plus C into 2n. That implies, by comparing the coefficients, let us compare the numerator and denominator, then we will get it as 1 is equal to A into 2n minus 1 whole square plus B into 2n into 2n minus 1 plus C into 2n. Let's expand this as we have done in the previous example. A into 4n square plus 1 minus 4n plus B into 2n square minus, not 2n square, it is 4n square, 2n into 2n, 4n square minus 2n plus C into 2n. That implies 1 is equal to, n squares we will take on one side, n square into 4a plus 4b plus n into minus 4a minus 2b plus 2c plus 4a. Plus a, sorry, there is no 4a. A into 1 is a only. That implies, when you compare the coefficients of n square n and constant, n square coefficient is 0 on left hand side and right hand side it is 4a plus 4b. 4a plus 4b is equal to 0. N coefficient on left hand side is equal to 0 and right hand side is minus 4a minus 2b plus 2c is equal to 0. On left hand side the constant is 1 and right hand side it is a is equal to 1. This is what we have got. Now solve these three equations for three unknowns. A is equal to 1. 4a plus 4b is equal to 0. Therefore, b is equal to minus a. That is minus 1. 4a minus 2b minus 4a minus 2b plus 2c. It is not c, it is 2c. Minus 4a means minus 4, minus 2b means plus 2, minus 4 into 1 minus 2 into minus 1 plus 2c is equal to 0. That implies minus 4 plus 2 is minus 2, minus 2 plus 2c is 0. That implies 2c is equal to 2. That implies c is equal to 1. That means a is equal to 1, b is equal to minus 1, c is equal to 1. Then you put these values in the equation. an is equal to a by 2n plus b by 2n minus 1 plus c by 2n minus 1 whole square. That is equal to, that implies an is equal to nth term in the series is equal to a by 2n is a1 by 2n, b by 2n minus 1 is minus 1 by, because b is minus 1 by 2n minus 1 plus c is 1 plus 1, hence it should be c by 1 by 2n minus 1 whole square. That implies the total series will be sigma n is equal to 1 to infinity is equal to sigma n is equal to 1 to infinity. an you put this value 1 by 2n minus 1 by 2n minus 1 plus 1 by 2n minus 1 whole square. That implies the given series value will be sigma n is equal to 1 to infinity 1 by 2n minus 1 by 2n minus 1. This is 1 plus sigma n is equal to 1 to infinity 1 by 2n minus 1 whole square. This is equal to 1 by 2n minus 1 by 2n minus 1. What happens? 2n minus 1, it goes there. This will be, when you write in a expanded way, 1 by 2 minus 1 by 1 plus 1 by 4 minus 1 by 3 plus 1 by 6 minus 1 by 5 plus goes on. This value. This is this value. This is this value plus, let us try to do next this one. Just wait for finalizing this value 2n minus 1 whole square. If you think of this value, this can be written as, this is equal to, let us take minus out, then it will be 1 by minus half plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus sigma n is equal to 1 to infinity 1 by 2n minus 1 whole square. What is the value of this? One minus half plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6. Alternate plus and minus. This sum is a standard series value, that is a standard series value. I am not deriving this value here. You treat it as a homework and derive from standard textbooks. They will have the derivation. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. This is nothing but ln2. Hence, this series will be sigma n is equal to 1 to infinity is equal to minus ln2 plus. Now we have to find out this value. N is equal to 1 to infinity 1 by 2n minus 1 whole square. What will be its value? In the last lecture, we have seen that sigma n is equal to 1 to infinity one by n square is equal to pi square by 6. This is sigma n is equal to 1 to infinity 1 by n square is equal to pi square by 6. This is the standard value, which we have even used in the previous lecture. Now, what is 1 by n square? 1 by n square is nothing but 1 by even numbers square plus sum of the odd number square. Why? It is 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square and so on. 1 by n square is equal to 1 by n square is equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus 1 by 5 square plus so on. Please try to understand the concept here. That is 1 by n square is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on plus 1 by 2 square plus 1 by 4 square plus 1 by 6 square plus so on. That means sum of this is sigma. Sum of odd number squares 1 by sum of reciprocal odd number squares. Sum of odd reciprocal square. Here sum of even reciprocal squares. That implies sigma 1 by n square is equal to sigma 1 by 2n minus 1 whole square from n is equal to 1 to infinity plus sigma n is equal to 1 to infinity 1 by 2n whole square. This value we know, this is pi square by 6 sigma 1 to infinity n is equal to 1 to infinity 1 by n square sigma is equal to pi square by 6, that is equal to 1 by 4 into sigma n is equal to 1 to infinity, even numbers if you take 1 by n square plus sigma n is equal to 1 to infinity 1 by 2n minus 1 whole square. Just see, it is a rearrangement only. That means pi square by 6 is equal to 1 by 4 into pi square by 6. Plus sigma n is equal to 1 to infinity 1 by 2n minus 1 whole square. That means sigma n is equal to 1 to infinity 1 by 2n minus 1 whole square is equal to pi square by 6 minus pi square by 24. That is equal to pi square into 4 minus 1 by 24. That is equal to pi square by 8. This value is pi square by 8. Now, what is the sigma an? Ultimately, sigma an n is equal to 1 to infinity is equal to minus ln2 plus pi square by 8 by substituting the above values. This is proved. With this, I wanted to conclude this lecture, and it's a very good example. Please try to understand the concepts in it. Do the best in the examination. Once you understand the concept, you will be able to solve any type of this type of problems, and best of luck to you all. And if you feel there is a value addition to you because of this lecture, kindly share and subscribe to my channel Maths and Science by IITian. Thank you. Best of luck. Thank you for seeing my lecture. Thank you for listening to me. Best of luck.